lesson is 7.3 multivariable linear systems. We're going to start off with something that's called row echelon form and back substitution. The reason it's back substitution is because you're already starting off with one of your solutions. You already know that z equals 3, and all you're going to do is you're going to start down here at the bottom and you're going to substitute in, and then when you get the solution for this system, you're going to substitute in back up here. And you notice that you have three equations in your system and you have three variables. So in your solution over here, we are going to have what's called an ordered triple. So instead of just an x and a y solution, we are actually going to have an x, a y, and a z for our solution. And we already know that z is 3, so I'm going to go ahead and put the 3 in there for the z. So I'm going to start by putting the 3 back in. I'm going to go back up here to the second equation because it's smaller, and I'm going to plug the z in, or the 3 in for the z right here. So y plus 3 times, plug the 3 in right there, times 3 equals 6. Well, 3 times 3 is 9. So y equals, that's 9. Subtract 9 from 6. 6 minus 9 is negative 3. So y equals negative 3. So if I know that y is negative 3 and z is positive 3, then I can now come back up here to this top equation and I can plug in for z and for y, and I can find out what x is. So let's do that over here. 2x minus, and in place of y, always put parentheses when you substitute. In place of y, I'm going to put negative 3 plus 5, and in parentheses, because I'm going to plug in for z, that's 3, equals 22. And you need to sharpen up on your algebra skills here. Solve that for x. That's 2x plus 3 plus 15 equals 22. 2x, 3 plus 15 is 18. Subtract that from 22. That's 4. And so x equals 2. And there is your solution. There's your ordered triple. 2, negative 3, and 3. For example 2, we're going to use something that's called, our pre-cal book calls this Gaussian elimination. In Algebra 2, we just simply called this elimination, or we called it addition method. It's just simply getting rid of the x or the y by multiplying one of the equations by one or both of the equations by a number, so that when you added the two equations together, either your x's or your y's canceled out. So don't let the new term in there throw you off. So if I look at this equation, I want to add these together so that when I add them, either the x's or the y's cancel out, and it doesn't matter which one. So I'm looking at this and I want to cancel out my x's. If I want to cancel out my y's, I could do that. It doesn't really matter. And this should be a review all the way back from Algebra 1. You've been doing this for the last several years here. I'm going to get rid of my x's, so I'm going to multiply by negative 2, and I have to multiply the whole equation by negative 2, because to make the x's cancel out, this x has to have a negative 2 to cancel out with this positive 2. So my top equation will stay the same. I'm not changing that at all. 2x plus y equals 90. But this bottom one will change to negative 2x minus 4y equals negative 180, because I have to multiply the entire thing by negative 2 all the way through. Now I'm going to add it straight down. If I add the x's straight down, they will cancel out, which is what I wanted to happen. If I add the y's, that's negative 3y. And if I add these numbers here, that comes out to be negative 90. So solve for y, and y equals 30. So in my solution here, if you notice, this is a smaller equation or smaller system than what we just got through doing. We only have x's and y's, so I will only have x's and y's. I found my y was 30. So to find the x's, I'm going to go back and substitute in. You can substitute in for this equation, or one of these other two. Doesn't matter, just pick a place to go substitute it. I am going to substitute back in this equation, just because that's the first one. You know, it doesn't really matter, just pick one. 2x plus, in place of y, I'm going to plug in a 30, and that equals 90. So solve that. 2x equals 90 minus 30 is 60, and x equals 30. So x is 30 and y is 30. For example 3a, we are going to solve this big system, this 3-variable system, 3 variables, 3 equations by hand. And this is probably the first time that a lot of you have done this, because in Algebra 2 we did not do these by hand. I'm going to go ahead and get my solution set up over here. I'm going to have 3 variables. I'm going to have an x, a y, and a z, an ordered triple. And the hard part about some of these, for some of you, at least until you get going on them, is knowing where to start. But if you look in here in the center, do you notice that if you add, just look at these bottom two equations, if you add these bottom two equations together, the y's will cancel out and the z's will cancel out. Because of that, I'm going to choose to just work with the bottom two equations right now. We'll come back and deal with the top one, but right now let's just work with these bottom two and let's add them together and see what happens. So let's add them together. 2x plus 3x is 5x. Your y's will cancel. Your z's will cancel. 3 plus 2 is 5. And to solve for x, you divide by 5 and x equals 1. So even though that looked kind of long, I ended up getting just x equals 1 out of that. So I know that one of my variables is 1. If I know that x is 1, then I can go plug a 1 back in to any of these equations and make them shorter or smaller. I can eliminate one of the variables. So I'm going to do that for 2 of the equations, and it doesn't matter which 2, just pick any 2. I am going to go with the first one. So let's go to equation number 1. And I'm going to plug in a 1 for x. So 1 plus y plus z equals 6. Subtract 1 from 6. So y plus z equals 5. Okay, I need another equation that I can put with this one so I can work with these two together and solve for y and z. So I need to go plug the 1 back into another one of these equations. And again, it doesn't matter which one. I'm just going to choose the second one. So let's take the second equation and go plug a 1 back in for x. So I'm going to do 2 times 1 minus y plus z equals 3. So this is going to be negative y plus z equals 2 times 1 is 2, and then you need to subtract that from 3, and you're going to get 1. So now I have 2 smaller equations. So what I'm going to do is I'm going to take this equation and this equation, and I am going to put them together as a smaller system like this one that we just got through working, like you're more familiar with working on. Okay, so let's write those 2 together. Okay, so now I have y plus z equals 5. Negative y plus z equals 1. And now we can solve this smaller system and find out what y and z would be. I want to add them together. Luckily, if I go ahead and add them together, I'm going to have the y's cancel out, so I don't have to multiply one of these equations by something. But if you needed to, you would have to multiply one of these equations or both of them by something to have the y's and the z's cancel out. But my y's are going to cancel, so that's going to cancel out and be nothing. Z plus z would be 2z. 5 plus 1 is 6, so z would equal 3. So z is 3. Okay, I still need to know what y is. If I know that x is 1, and I know that z is 3, I need to go plug those in somewhere, anywhere that I can to find out what y is. Make it easy on yourself. Find one of your smaller, shorter equations, like, pick this one or this one, which is these, and plug it back in and find out what y is. How about right here? If z is 3, y plus 3 equals 5, so y's got to be 2. So there's our solution right there. It happens to be 1, 2, and 3. And we got several more of these to do so you can practice. On this next example, I don't see where anything in the middle here is going to cancel out. And by the way, if there's nothing here for the z's, that's like a 0 z right there. But I don't see anything in the middle here that's going to cancel out like the previous example. But I do notice with these top two equations, the x's are going to cancel. The reason on this previous example, the reason I went with these last two equations is because I noticed that the y's and the z's would cancel. But most of the time, just to be consistent, I will work on eliminating the x's. So usually I will just go ahead and eliminate eliminate the x's. Just to be consistent, I will eliminate the x's. And that's what I'm going to do on this problem. And it actually works out good because if you'll notice with my first two equations here, if I will add those two together, look what happens. If I add them just like they are, x plus negative x, the x's do cancel. And if I add the y's together here, that's going to give me 1y. And if I add my z's together, that's a 0, z right there. So 3z plus 0z is going to give you 3z. And then 9 plus negative 4 is 5. So by adding equation 1 and equation 2 together, I got y plus 3z equals 5. And the x's are gone. So now I need to work with another set of equations. I can either put the first one and the last one together, or the second one and the last one together, and try to get rid of the x's. So I'm going to come down here and I'm going to work on the second one and the third one. It doesn't matter which ones I group together, I just need to pair up another set of equations, not the first two that I grouped together. And I need to get rid of the x's also so I can have only y's and z's to work with. Excuse me again. So I'm going to rewrite those equations that I'm going to work with here. Negative x plus 3y, and I'm going to put my 0, z in there. And 2x minus 5y plus 5z equals 17. Now, in order to add these together, and remember, I am eliminating the x's. That's my whole goal here, is to get rid of the x's. I want my x's to cancel out. So in order for that to happen, I need to multiply this top equation by 2 so that these x's will cancel. So I need to multiply all this by 2. So my top equation is going to become negative 2x plus 6y plus 0z equals negative 8. This bottom one did not change any at all. Okay, draw your line. Let's go ahead and add them together. X's cancel. That's 1y plus 5z equals 17, and negative 8 will give me 9. Now I have eliminated the x's. So I have this equation with only y's and z's, this equation with only y's and z's, and what I want to do is I want to put those two together and work with just those. So I have y plus 3z equals 5, and y plus 5z equals 9. And I want to continue solving this so that I can find out, well, I'm going to go ahead and set this up over here. You know that we're going to have an x and a y and a z, and I haven't found any of them yet, but I'm getting close. Okay, so I need to eliminate either the y's or the z's. If I were to multiply one of these equations by -1, and it doesn't matter which one, I'm going to do this bottom one just because I have more room here. I'm going to multiply all of this by -1 so that my y's are going to cancel. So I'm going to leave the top equation alone. Y plus 3z equals 5. Negative y, negative y minus 5z equals -9. Combine those or add down. Negative 2z equals -4. So z equals positive 2. Okay, so I have one of my answers. Z is 2. Let's find out what y is. Go plug in a z in. Now don't go back to the original. You're not going to get very far. You want to go plug in the z, the 2, in for one of these equations, or one of these right here, where you only have 2 variables. So I'm going to go plug it in right here. I'm going to plug in a 2. Y plus 3 times 2 equals 5. So y is going to equal -1. Now you need to go back into one of your original equations to find out what x is. And if you'll go plug that back in, go plug it back in somewhere and find out what x is. I'm going to go plug it back into this little short one right here. Negative x plus 3, I don't even need to plug in the z right there because there's no z, times -1 equals -4. So negative x equals -1, x equals positive 1. And there's your ordered triple, your x, y, and your z. 1, -1, and 2.